Hey guys, Mr. Decker here, and we are back. We're on Lesson 9, Sprite Properties in the updated Code.org CS Discoveries Unit 3 Games and Animation Curriculum. Holy moly, that's a mouthful. All right, so let's knock out this prediction bubble. It says, look at the code below and predict where the B sprite will appear. What will the program show? All right, so where is that B sprite going to appear? We have middle of the screen, bottom right corner, two B sprites, one in the middle and one in the bottom right hand corner. Option D is three B sprites, all in different places, or nothing. There will be an error. Let's see. We've got variable B on line 1 gets the create sprite X and Y properties of 200, 200, which is right in the middle of the screen, or right in the middle of the display area. And then we're setting the B animation to a B. So I imagine it will actually be a B on the screen because all of these options say such. And then we're changing, or we're updating the X value to 350 and the Y value to 350, and then we're drawing that on the screen. So 350, 350 is way down here. So I think there's going to be one B sprite in the bottom right corner. B. Let's try it. Yes, I am the smartest man alive. All right. And if you got that right, you're probably pretty smart too. All right, let's finish and continue on to bubble 2. And on bubble 2, it says this level follows a video that you may have watched. If you want to watch it, it's on your help and tips tab. The instructions here say Sprite Properties keep track of all the information in our program. Or sorry, the Sprite Properties keep track of all the information our program needs to know about a sprite, such as its size, its location, and you can change the values of these properties just like you do with variables, and then you can see the results when your sprite is drawn to the screen. Do this. Run the program to see where the sprites appear. So let's run it. Okay, so we've got a paint palette here with gray, blue, red, green, and white on it. And then we've got our paintbrush up here in the top right-hand corner. It says change the location of the paintbrush to touch the paint palette. So we want to get the bristles of our brush dipped into one of these colors down here. We're going to change the Sprite X and Sprite Y properties of the paintbrush sprite to change its location. So remembering from the last lesson, we learned that the middle of the sprite is the X and Y location of it. So I don't want to just say 106, 280, because what will happen on line 9, let's just, for example, 106, 280. So 106 here for brush.x, 280 here for brush.y, reset run. See, it's dipping in the Y. I want it to dip into the blue. So I'm going to try 129, 237. And that might not even be exactly what I want. What did I say? 129 what? Let's try Y258. 258. Ooh, almost. Let's raise it up a little further. So we'll reduce this to like 240. There we go. Now my paintbrush is dipping its bristles into the blue paint, and that's what I wanted. So if you don't get it right the first time, like I didn't just get it right the first time, you kind of play around with these numbers until you figure it out. And it's not you're not guessing those numbers. You're using the X and Y properties. So like, you can see them there. You can see them under the reset button. As you are moving your cursor around, you can see the X and Y values changing right underneath the reset button. You kind of guess as to where you need it. So like right there, 129, 238 would also work. So let's click finish, and that will move us on to bubble 3. On bubble 3, we're working in new properties, and it says sprites have lots of properties. So let's check out the 2 new blocks in this activity and try them out for ourselves. Notice that different sprites can use the same animation and still look different because of properties. Do this. It says run the program to see what's different about the first two notes. So we run it. Okay, so note 3 and 4 are the same size. They're both big. Notes 1 and 2 are both kind of crooked or tilted, and they're both different sizes. So that's interesting. How do we do that? So it says, notice how the rotation and scale blocks make the first two notes look different. So let's take a look at that a little closer. So on note 1, it's set to a scale of 0.3. If you remember, on the last lesson, lesson 8, I believe, or somewhere abouts, we learned how to do scale, but this time it's really going to give us more details about how that works. One of the biggest things with scale is anything less than 1. So if it has a 1-to-1 scale, then it's the same size as its original size. So if you want it to be smaller than its original size, you select a number as a decimal point that's smaller than 1. So 0.3 is making note 1 basically a third of its normal size. And then note 1.rotation gets 20 is what is making it tilted like that or rotated like that. On note 2, on line 12 here, note 2's scale gets a value of 0.7. So this one is like 2/3, a little over 2/3 the size of its original size. And then on line 13, we're setting the rotation to -30. So -30 is making it lean to the left. And then that first note was set to 20. So that 20 is making it rotate a little bit to the right. That's good to know. So we're going to use those same blocks, the scale block and the rotation block, on notes 3 and 4 to make them look different too. So we're going to use the rotation and scale blocks on the last two notes. So down here we have note 3, and you see that there's no, we haven't set the scale or the rotation for that one. So we go to the sprites drawer. That's where the scale and rotation blocks live. I need to match that label, so that's going to say note 3 as well. And then I'm going to make this one bigger. I'm going to make it like 1.4. Reset run just to see. Yep, made it a lot bigger. And then I'm going to set the rotation as well. So note 3 rotation. Let's make it upside down. Let's see, 180 should turn it upside down, and it did. Sweet. And then let's do scale and rotation for note 4. So we got to match that label so the computer understands what we're changing. Otherwise, it'll be all confused. Let's make this one smaller, so we can do like 0. Let's say 4.5. Remembering that you can get as detailed as all the way to the hundredths place on your scale. And then for the rotation, let's make it -90 so that it lays flat. And then run it, and there you go. It's laying flat. Or completely horizontal would maybe be a better way to say that. All right, let's finish and continue. We're on bubble 4. Looks like we've got 3 practices, plural. All right. So we're setting the scale property. So the scale property changes the size of the sprite. A scale of 1 is the normal size. A scale of 2 is twice as big. And a scale of 0.5 is half as big. Do this. Fix the code so that it looks like the picture on the right there. All right. We can probably manage that. And then if you click that little arrow, it toggles more instructions for you. So it says use the scale property to change the size of each sprite. We can do that. So let's run it. Oh yeah. So we're trying to match this image right here. So we need to make the elephant smaller. So we'll go down here, make it like 0.7, reset run. Let's make the cow smaller. We'll make him like 0.5. And yeah, that looks right. That looks similar to the picture there. And then I want the fish to fit in the pond. So I'm going to make it like 0.3 maybe. Yep, there we go. The fish fits in the pond. And then the fly should be the smallest thing. I'm going to make it like 0.2. And there's the fly. So it's a little bit different from our picture, but the important thing is that the elephant is the biggest, the cow's the second biggest, the fish is the third biggest, and the little fly is teeny tiny, so that he can buzz around and be the pest that he is. All right, let's finish and let's go to bubble 5. Or sorry, not bubble 5. We're doing 4B now once it gets back to the practice screen. And we're working on rotation property. Probably going to be getting those cars lined up in their lanes. Yeah, that's exactly what we'll be doing. Okay. So the rotation sprite property rotates an image by between 0 and 360 degrees. And the image is rotated clockwise. For example, my sprite.rotation gets 90. We'll turn it 1/4 rotation to the right. Okay. So let's make all these cars look like they're traveling correctly down these roads. So we're going to add rotation property blocks to each of the car sprites, and we're going to play with the values to make sure the cars are going the right direction in the lane they're supposed to be in. So scale is already set for each one. We're going to go to our sprites drawer, and we are going to use the sprite.rotation block for each of the cars. So for the car top, that's this green one, I imagine. He's already good. I don't need to do anything with that one. He's already set. He's on his way in the correct lane. The blue one I need to flip. Let's see. The car bottom would be the blue one. So we'll grab that sprite.rotation. We'll say car bottom with a capital B to make sure that matches up. And then I want to completely flip that 180 degrees. Take that back out. Reset run. Now he's going the correct way. This one here, that's the car left. Car left is the red one. So let's fix the red car's rotation. Car left with a capital L. Matching that variable label. And then I need it to face this way. So I'm going to do minus 90. Turn it 1/4 to the left. Actually, no. If it's in that lane, it needs to be 90, right? Be facing the correct way. There we go. And then for this yellow one, it's going to be interesting because it faces at a diagonal. So let's see if we can find the right diagonal for car right. So sprite.rotation is going to be car right.rotation with a capital R. And let's try 45 degrees. Perfect. All right, so for the green one, we didn't have to do anything. It's facing the correct way already. For the red one, that's car left. We rotated it 90 degrees. For the car bottom one, this blue one down here, we rotated it 180 degrees. And for car right, this yellow one, it needed to be at that diagonal, so we chose 45 degrees. Let's continue on. I think that's going to put us on 4C, multiple properties. We're rotating, we're going to set the rotation and the scale so they look like they're floating in space. We can do that. All right, so we've got 1, 2, 3, 4 sprites on the screen. Oh, and they're all discombobulated. So let's do this. We're going to practice using the scale and rotation sprite properties in order to fix the scene. We can try to repeat that. So let's go for it. So for the space one, let's go to the animation. Space is that one. So we don't need to do anything to space because space is already good. That's our background sprite. Let's see. So the next thing to do would be the comet. And the comet looks like this. We want it to look like that. So actually, let's do the astronaut first, because he's blocking the view of everything else. So let's go to the sprites drawer. Let's grab scale. And let's set the astronaut's scale to like 0.3. Make him a lot smaller because he's huge. There we go. Make him even smaller than that. Let's go with 0.2. And then we're going to rotate him, matching those labels. We're going to rotate him to the right a little bit. Let's put him at like 35. Reset run. There he is. And then the comet. Let's do the comet next. We're going to set the scale of the comet to, let's say, 0.5 maybe. Reset run. All right, that looks good. And then let's rotate it. And we're rotating, we're basically kind of flipping it over. So let's see. Let's do like negative 120. See what that looks like. Nope. Let's try negative 180. Oh, we're getting there. Negative 230. Oh, we're close. 270. Let's reduce that just a little bit. Let's try negative 260. There we go. And then for our little alien sprite down here, where is he? Okay, lines 8 and 9. So let's set the scale of our alien sprite. Make him just a little bit smaller. So 0.8 maybe. That's good. And then let's set his rotation. He needs to go a little bit to the left. So maybe negative 30. Good. Perfect. That looks just like the sample image now. All right, let's finish and continue. And that's going to put us on bubble 5, which is probably our assessment bubble for this lesson. It looks like we've got a plate full of giant food here. Make it fit. The food is way too big to fit on the plate. Use your knowledge of sprite properties and make it fit. All right. So run the program to see how big the food is. We did. And then use sprite properties to scale all the food sprites down so they fit on the plate. So we go to sprites. We're going to use sprite.scale for each thing. But first, let's do fries. And let's go ahead and just do 0.7 for everything. And then we can come back and mess with the size if we want to update it again. 0.7 for the burger. And then another sprite scale on line 14. Match the label to dessert, 0.7. Let's see how that looks. All right. We got to go a little bit smaller on the burger. So let's try 0.5. Make sure he's on the plate. Let's make that burger a little bit bigger. I'm hungry. There we go. 0.6 works for the burger. And then for the watermelon, let's try 0.6 there as well. 0.6 on line 14. Yeah, perfect. All right. I like it. All right. I believe that's going to put us on to bubble 6, which is going to likely be our challenge level. All right. So we're choosing from the following activities, but I'm going to do all 3. New block tint. We're going to adjust the sprite's color with tint. Tint is a property that will overlay a color on top of a sprite to tint it. This tint doesn't change the existing colors of a sprite, but is more like putting a pane of colored glass over the top of the sprite. Do this using either the sprite already created for you or with any other sprites of your choosing. Play around with the tint property and see how it works and how it changes on different colored sprites. All right, make sure to put the tint color you would like in quotation marks, example, red. So let's go to the sprites drawer. Let's grab sprite.tint. We're going to change that to creature.tint. And then in quotation marks, let's try red. It suggested that, so let's try it. Oh yeah, bright red. Okay, so let's see what happens if I do like purple, and then there's all kinds of colors you can choose from. So if I did like magenta, that's probably there. Oh yeah. Okay, cool. That's the tint. So I guess if you don't like the color of a sprite, you can change the tint. And that would save you from having to go to the animation tab and color it there. All right. So you learned about the scale property, which grows or shrinks a sprite while keeping their height to width ratio the same. But it is possible to only change the height or width of a sprite with other properties. So let's go to the sprites drawer. And now we have height and width blocks down here. And now it says do this using either the sprite already created for you, which is this giraffe, or with any other sprites of your choosing. Play around with the height and width properties and think about when you would want to use these properties versus using the scale property. All right, so it's a giraffe. Giraffes are tall, right? So let's go in here, sprite. Oh, it was already sprite, wasn't it? Sprite. And let's make it like 1.5. What does that do? Oh, wow. Makes it really small. So it, whoops, what did I do? So it doesn't quite work like the scale. Let's try a different number, like 200. Okay, so now it's kind of a squat giraffe. Oh, okay, I understand. So this is making it 200 pixels tall. Remember that the display area is 400 pixels tall total. So let's see, we could probably do like 375. Yeah, there we go. Now he's big. And now let's go to width. And remembering it probably works the same as height. So you're determining how wide it is by the number of pixels. So let's see what 200 does. All right, makes them a little wider. Let's try 350. Now he's a really big giraffe. He's like an NFL lineman giraffe now. All right, cool. Let's finish that one. Oh, wait, but if I wanted to make him really skinny, I could do like 120 maybe and be like a normal giraffe. Let's try 90 and make him even skinnier. Only 90 pixels wide. There we go. Now he's like a tall wide receiver or like a center in basketball. Finish. Continue. All right. And then new block alpha. Okay. Adjust the sprite's transparency. Oh, cool. So if I'm using a ghost or something, I can make it transparent? That's neat. Okay, so alpha is a property that can control the transparency of a sprite. It uses decimal values to represent transparency. So alpha gets 1 would not be transparent at all. It will look like a normal sprite. Setting it to 0 would be completely transparent and it will look invisible. And then 0.5 would be 50% partially transparent, like it's see-through. Okay, that's a good explanation. I like that. It works a lot like scale does. Using either the sprite already created for you or with any of the other sprites of your choosing, play around with the transparency and see how it works and how it changes on different sprites. Okay, so run. All right, we've got that same scene there. We're not changing the transparency at all there. So let's go grab sprite.alpha. Let's match that. Ghost.alpha, let's make it like 0.5 like it suggested so that it's transparent. I like that. So if I did like 0.1, oh, you can just barely see him now. If I had 0.9, you probably see him pretty well, but you can just barely see the door through him and see those bricks through him. But I really like 0.5. That seemed like the natural thing for a ghost because you can really see him well, but you can also see through him really well also. So I'm curious. If I do like 3.5, I also like that a lot. Okay. That's pretty neat. What did it say here? Using the sprite already created for you or with anything else, and try it with different sprites if you want to. All right. We will leave it right there. So finish. That's the end of lesson 9. And that's all we need to do. This one was really short and sweet, but it was also really fun to do. Also really easy, I felt like. All right. At least compared to like drawing the shapes on the screen and doing all that with the robot face, this was way easier. I hope it continues to make sense and be easy for us. All right. As it turns out, coding is not that hard. It's not all that wizardry that some people think of it as. All right. We'll stop right there. I hope you guys had as much fun as I did. I'll see you back here, same place, for lesson 10.